Hello friends, welcome back to Coding Theory Guru. In today's video, we are going to learn one of the most important software developments models. Okay, see V model in software engineering. The V model, also known as the validation and verification model, is an extension of the traditional waterfall model. It emphasizes the relationship between each development phase and its corresponding testing phase. See, the V model, also called the verification and validation model. Okay, don't worry, I will explain it in a simple and student friendly way. Okay, the model is shaped like the letter V, where the left side of the V represents development activities, the right side of the V represents testing and validation activities. The bottom point is the coding phase connection both sides. See, so first, what is the V model? Think of it as an upgraded version of the waterfall model. But instead of just moving straight down like waterfall model, here the process takes the shape of the letter V. Okay. On the left side of the V, we have all the development activities like requirement analysis, system design, detail design. On the right side of the V, we have the testing activities that directly correspond to each development step. And at the bottom point of the V, we have coding which connects both sides. Okay. Phases of the V model: requirement analysis, acceptance, testing. Requirements are gathered from the client, later validated through acceptance testing to ensure the product meets user needs. See, first is requirement analysis. Here we gather requirements from the client, then later these requirements will be tested using acceptance testing. Basically, this ensures we are building what the customer actually needs. Okay. Second is system design, system testing. The overall system architecture is designed tested at the system level to check overall functionality. See, once requirements are ready, we design the overall system architecture. Later, this will be validated through system testing. Third is high level design integration testing. The system is broken into modules and their interaction is defined. Integration testing ensures modules work together correctly. See, at this stage, we break the system into different modules, okay, and define how they interact with each other. And the corresponding test here is integration testing, which checks if models work together properly. Okay. Then low level design unit testing. Detailed design of individual models is created. Each model is unit tested after coding. Okay. Low level design. Now we design each model in detail. Okay, this phase connects with unit testing, where every single model is tested individually. Okay, then coding. The actual implementation of the design into code connects development with testing activities. See, finally we write the actual code. Okay, finally we write the actual code. After coding, we move upward on the right side of the V to perform all those testing phases. Okay. Advantages: testing is planned early, reducing defects, easy to manage due to structured approach, ensures quality through step by step verification and validation. See, the beauty of the V model is that testing is planned very early. This reduces errors and ensures high quality. And it's also very structured and easy to manage. Okay. Then disadvantages: not flexible if requirements change later, costly if changes are needed after design, best suited for projects with stable requirements. See, but the drawback is that it's not flexible. Okay, if requirements change in the middle, then it's very costly and difficult to handle. That's why it's work best when requirements are stable. Okay, in short, the V model ensures that each development phase has a directly associated testing phase, making it highly disciplined and quality focused software development model. See, in simple words, the V model ensures that every development step has its matching testing step. Like it's all about verification and validation, making sure we build the right thing and we build it correctly. Okay, thank you.